Welcome students. In this video we are going to discuss about the reliability and other factors of DC transmission systems. In previous video we have discussed about the economics and technical performance of the HVDC transmission system. So this video will be completely dealing with the reliability and other factors that supports the DC transmission. So let us start with reliability. So reliability refers to the ability to rely on a particular system. This is the basic meaning. When it comes to the meaning of power system reliability, so power system reliability is defined as the ability of the system to satisfy the customer's demand. So what is the customer's demand? The customer's demand is to expect the transmission system to work perfectly without any faults, without any interconnection issues, without any issues in the transmission, and with proper and effective way. This is what the customer expects, right? So obviously students, this power system reliability is the ability of the system to satisfy the customer demand. So based on the existing study, HVDC links have better reliability when compared to AC transmission systems. We already discussed a lot in the previous videos, like AC transmission systems requires a large number of conductors. When it has large number of conductors, it will incur a huge amount of losses. When compared to HVDC, HVAC has large losses, so losses reduces the reliability level. And the development of thyristor valves improved the reliability considerably for HVDC transmission systems. Initially, we were using the mercury arc valves, but now with the advent of thyristor valves, the reliability increased considerably. And one more thing is that with the help of light triggered thyristor, so which is one of the new advancement, and new techniques of control and protection have improved the reliability levels of the DC transmission system. This reliability, next comes the reliability measurements. So reliability can be measured in terms of two factors. The first one is energy availability, and second one is the transient reliability. So let us start with the first one. What is this energy availability? So energy availability is defined as 1 minus equivalent outage time divided by total time. So it is always expressed in terms of percentage. So we can say that we know the total time. Total time is total time taken, and equivalent outage time refers to the product of actual outage time and the fraction of system capacity lost due to the particular outage. So based on this, we can say that energy is available to a particular percentage level. So this is one of the major measure of reliability in transmission system. And next measurement is the transient reliability. So we can define the transient reliability as 100 multiplied by number of times HVDC systems performed well as designed divided by the number of recordable AC faults. So recordable AC faults refers to the faults which can cause one or more AC bus phase voltages to drop below 90% of the voltage prior to the fault. So this is what we call it as recordable AC faults. Both energy availability and transient availability of existing DC systems with thyristor valves is 95%. So there also in previous skills also energy availability is 95%. Here transient reliability or transient availability is also 95%. DC bipolar line considered to be more reliable than double circuit AC line. In the event of failure of one pole of DC system, the other pole can supply 50% of the with the ground return. So which is not possible in case of an AC system. And other factors favoring DC transmission system. The first factor comes here is the over voltage. The switching surge, that is nothing but over voltage levels in HVAC, high voltage AC transmission, is 2.5 per unit, but in case of HVDC, it is only 2 per unit. And next comes the reliability. When it comes for fault in EHVAC lines, more than 50% of the total capacity is lost, but in case of HVDC, at least 50% will be served. That means which will be supplied. So it is more than 50% here, at least 50% is working, so it is comparatively HVDC will be reliable. And next one is the power transfer capacity of EHVAC. So the power transfer capacity of the EHVAC line depends on the following factors. The first one is sending end voltage, receiving end voltage, line reactance, and phase angle between the sending end voltage and the receiving end voltage. So we can express the formula of power transfer capacity as Vp is equal to VSVR sin del divided by X. So when line length increases, what happens? Obviously, reactance increases. So we know already length of the line is directly proportional to that of the reactance. So line length increases, reactance increases, power transfer capacity decreases. So with increase in this value, obviously will drop the power transfer capacity. So shunt and reactors and series capacitors are required to compensate this reduction in the power transfer capacity. And we can see that in previous case we have seen about AC system. In case of DC system, it does not depend on any voltage or any technical things. It depends only on thermal condition, current carrying capacity of the conductor, and it is the function of difference of voltages at the two ends of the line. So stability limits. So next factor is the stability limits. So already we have discussed about this. The AC stability is comparatively less, but DC stability is good. Corona and radio interference and skin effect of corona and radio interference is less in DC transmission, and there is no skin effect, but in case of AC, skin effect is very much prominent. Next factor is cable for underground or undersea transmission. No reactive kVA or charging current in DC transmission, so obviously we don't have the reactive power requirement and charging current in DC transmission. No dielectric loss in cables. So as these two things are not there, the working stress in DC cables is about 400 kilovolt per centimeter, whereas in AC cables it is only 100 kilovolt per centimeter. So as the working stress of the DC cable is higher, thinner insulation can be used in DC transmission system, and effective power transmitted by a DC line is 2.5 times that of the power transmitted by the AC line. And next factor is the reactive power compensation. So electrical angle degrees theta can be represented in terms of L into root of capital L divided by C, where small l refers to that of the length of the line, capital L refers to that of the inductance of the line, capital C refers to that of the capacitance of the line. So power transfer through the line P is given by Pn secant theta, where Pn refers to that of the natural loading on the line. To maintain the constant voltage, we need to supply lagging reactive power for light loads with the help of shunt reactors, and we need to supply leading reactive power for heavy loads by shunt capacitors. Next is AC interconnection problems. Presence of large power oscillations that may lead to frequent tripping, increase in fault level, transmission of fault from one system to another are the problems that we are getting when we are using EHVAC transmission systems. But in case when we are using a DC, we will not have all these issues. And next one is power control in DC links eliminates all the above problems. That is what we have discussed already. Two AC systems with different frequencies must be interconnected through a DC link only. We can recall the interconnection of our grids, which is one of the best example in terms of the factors favoring the DC transmission. So students, that's all about this video. Let's recall what are the things that we have discussed. We have discussed about the reliability and what are the measures of reliability as energy availability and as well as the transient reliability. And we have deduced that the transient reliability and energy availability is 95 percentage and higher for HVDC, and it is very less for HVAC transmission systems. And we have discussed many other factors which is supporting the DC transmission system, like we have discussed about the AC interconnection problems, we have discussed about control, we have discussed about the surge voltage levels and all the other factors, and we have discussed about power transfer capacity also. In AC, it is dependent on many other factors like voltage, reactance, angle between voltage, sending and receiving and voltage. But in case of HVDC transmission system, it does not depend on all these factors. It depends only on the thermal capacity and charging current. That's all. So comparatively, when we are seeing, we can justify that HVDC transmission system is better. But still, we cannot say it will completely take up the AC and we will directly use DC in all the other cases, which is not possible. Economically, we have discussed the other factors. In majority of the videos, we have discussed about these things. So I don't want to repeat that again and again. So HVDC has its own advantages, but it can be utilized only for specific cases, case to case basis, based on the future developments, based on the requirement, based on the cost involved of the project. Everything the power system planner will account and they will start working on it. So that's all about this video, students. Thank you so much.